Welcome to Monochemistry. Today we're going to continue our discussion about kinetics by looking at the rate law. We're going to talk about rate laws, reaction orders, and we're even going to do a problem where we solve for the rate law and the reaction orders. Before we start that though, I'm just going to introduce you a little bit to the topic here. So let's say we have an equation here, as you can see, A plus B yields C plus D. What is the rate of that? Well, as per our last discussion, we know that every rate is associated with a rate constant. So the equation would be written as follows, and this is what a rate law is. A rate law is an equation that shows how to calculate the rate of a particular reaction. Okay, so the rate of this particular reaction, because we don't really know much about it, would be equal to K, the rate constant, times the concentration of A, because remember, rates are dependent on concentrations. K times the concentration of A raised to the X power times the concentration of B raised to the Y power. Now why X and Y? Simply, we don't know how much the concentration of A affects the rate. We also don't know how much the concentration of B affects the rate. It may have no effect. It may have a negative effect. It may have a positive effect. It depends. And so until we know what it actually does to the rate, we can't say for sure what it is. Okay, so we leave these as unknowns until we can actually show via experiments how quickly or how much A and B affect the rate. Note, and this is very important, that X and Y are not the coefficients A and B. So if this was a 2 and this was a 3, I would not put a 2 here and a 3 here. That is not ever how that works. Anybody who is caught putting coefficients here and here will fail the course. All right, let's move on. Okay, so we know how to write the expression or the equation for the rate law, but let's talk about the reaction order. The reaction order is in essence a sum of how much A and B in this case will affect the overall rate. Okay, so in this case the reaction order, let's call it the reaction order, would be equal to whatever X is plus whatever Y is. In general, the reaction order is simply the sum of the exponents of A and B, or whatever your reactants are. Okay, so we don't know what this is yet. All we know is that it's going to be X plus Y. We'll figure it out later on. Let's try a problem. Calculating reaction orders. I know you guys love doing math. This is probably some of the best math we're going to do this year. It's really awesome. Okay, so this is called there's two different types of rate laws. This is the only one you're ever going to have to write in terms of actually determining, and it's called a differential rate law. There's also an integral rate law. Calculus terms. When you get to calculus, you'll appreciate it, but right now we don't need to use calculus to solve it. But that's where those terms come from. So there's a differential rate law, which is this one here, that we're going to work on, and later on in another lesson we'll talk about the integral rate laws. But for right now, let's just look at the problem. The problem says write the rate law. Okay, so there's one thing to do. Write the rate law, determine the overall value for the rate constant K. There's two things to do, and the overall order of the following reaction. Okay, it gives us an equation. We have nitrogen monoxide plus chlorine gas yields 2NOCl. And it gives us some experimental results. Experiment 1, concentrations of each of those and the rate. Experiment 2, rate. Experiment 3, rate. Experiment 4, rate. Okay, so what the heck are we going to do with these? Okay, so you guys are going to do this problem. You're going to solve for all three of those things, and you're going to bring your answers to class. I'm going to help you with the first part, and then you guys are going to do the rest. So make sure you write this, copy this down, have it somewhere so you can bring it to class. So, the general equation we're going to use to help figure out, and this is to help figure out what X and Y are. So this is X, we're going to have an X and we're going to have a Y. This is the equation that we're going to use to help figure out what X and Y are. Okay, so the bigger rate over the smaller rate, and these are the values that go with the bigger rate. So let's say we're using experiments 2 and experiments 1, the bigger rate would go on top, and these values would go on top. Okay? So whichever one's bigger, you always put the bigger one on top. It doesn't necessarily mean, because in the experiment order, I mean, experiment 4, in theory, could have been experiment 1. So the second rate is always the bigger rate, whichever of these numbers is bigger, and these numbers always correspond with whatever the rate is for that. Okay, just be clear on that. Okay, when using this equation, it's very important that you look for two experiments. And in this case, we're going to solve for y. And the reason we're going to solve for y is because it's the easier one to solve for. I'm going to show you what I mean by that. I'm going to use experiments 1 and 3 to solve for y. Now, how did I know to use those two experiments? Well, in those two experiments, the concentration of Cl2 changes, but the concentration of NO does not. And that's very important. We can solve for y only if we can eliminate the concentration of NO out of our equation altogether, because we don't know what x is. So we can solve for y if we can eliminate the x from our equation. Okay, so let's plug in the values. Rate 2 in experiment, or in this case, it corresponds with experiment 3, is 2.86 times 10 to the negative 6. And the values that correspond with that for NO are 0.250 raised to the x power and 0.50 for Cl2 on top. On the bottom, experiment 1, we have 1.43 times 10 to the negative 6. And we have 2.250 raised to the x and 0.250 raised to the y, because those are the values that go along with NO and Cl2. Okay, so all I'm doing here is substituting the numbers from the chart that I gave you into the equation. Okay, now, really quickly, without doing any kind of fancy funky-dunky math here, 2.86 divided by 1.43. Quick, what is it in your head? That's right, it's 2. Sam, I know you got that right off the bat. Now, that's going to equal. What's that going to equal? Well, let's have a look over here. Notice that those two values, because they have the same exponent, can be canceled out. They're constant, and we're going to end up with a 1. So you cross those off. They're not part of our equation anymore. 0.5 divided by 0.25, 1/2 divided by 1/4 is going to equal 2. To the y. Now, 2 to the y equals 2. What does y equal? Well, y is an exponent, so it can only be a whole number. Well, that's not entirely true. In this case, it's only going to be a whole number. It can either be 0. 2 to the 0 would not equal 2, though. It can be a 1, it can be a 2, it can be a 3. But what's 2 to the 2 power? Well, that would be 4. So that's not right. So y has to equal 1. So the value of y in this equation is 1. All right, it's your turn now, the slightly harder one. Okay, I've got everything set up here for you. I'll even show you what cancels out. This time we're going to use experiments 1 and 2 to solve for x. I'm going to cancel that out. I'm going to cancel that out. Okay? You got to solve for x. Then you have to write your rate law. Then you have to solve for the rate constant. And then you have to tell me what order it is. Bring your answer to class. That, in a nutshell, ladies and gentlemen, is how you calculate reaction orders. And I can't wait to see your answers. Have a good one.